for Regents Review video number 10. So this first question we have here is a cross-section question. They tell us that they have a right cylinder, which looks like this. Again, that's just a cylinder that the side is perpendicular with the base, is cut perpendicular to the base. The shape of the cross-section would be what? So again, if I think of this as like a plane or a giant piece of paper, if I was to come in here and slice this so that it's perpendicular with the base here, what shape would I have? So again, if you think about it here, easiest way to kind of envision this is, let's see, if we kind of go from here. So I got my lines here. Let's do this a darker color, right? We've got our lines here, right? And that would come across like so, right? That would give us that kind of shape. So if I was to kind of take the cylinder, slice it straight down the middle here so it's perpendicular to the bottom, and I opened it up kind of like a book, the inside section would be this rectangle, right? So that gives me choice C as the answer there. All right, so whenever you're doing these cross sections, you got to envision what happens, what the inside piece of it would be. So basically, it's kind of like, in this case, like I said, if I split it straight down the center, don't mind my sketch here, but it looks something like this. Right, if I just kind of like opened it like it was a book, it would look something like this with this part here. That would be half the semicircle and the other half over here. So that the part that we're looking at is this piece here, right? That would be that rectangular shape that we have there. Okay. Second question, after dilation centered at 0, 0, the image of dB is d prime b prime. If dB is 4.5 and d prime b prime is 18, the scale factor of this dilation is what? So again, the key for this one is to remember that a scale factor, right, is equal to the image over the pre-image. So in this case, if I've got image and pre-image, that in this diagram, it would be d prime b prime. Oh, what happened there? Over dB. So that would be 18 over 4.5 for this example. So if I do a calculation of 18 divided by 4.5, I get an answer of 4, which gives me choice D. So key is just to remember when dealing with the scale factor, easiest way to think about it is image over pre-image, and that will indicate my ratio, and in this case, the scale factor. Lastly, we have question number 3, which is a geometric coordinate geometry proof question here. So we've got two parts. We've got to prove that in the first part that a quadrilateral MATH is a parallelogram, and then the second part that it is in fact a rectangle. So the important thing is, I have to do the parallelogram part first, and it kind of helps me out actually for the second part because I can't be a rectangle unless I'm a parallelogram. So if I get this to be no, then automatically I know the second part's going to be no as well, and we can kind of go from there. But let's see if we're a parallelogram first. So lots of things you can do to find that it's a parallelogram. My favorite way to do it is the diagonals. So I've already drawn the triangle, the rectangle here. This was M, this was A, this was T, and this was H. All right, so again, I like to use the diagonals when I'm dealing with these coordinate proofs whenever possible. So I'm going to be focusing on MT and AH. And that's because in a parallelogram, the diagonals will be bisectors of each other. So if I can prove that these two diagonals, if they intersect at the exact same spot, I know that they bisect each other. So the first thing I'm going to do is I'm going to find the midpoint of, let's start with MT. Key for these questions is organization, right? The more organized you are, the better you're going to be. So midpoint of MT, I'm going to say here, midpoint formula, that's x1 plus x2 divided by 2, y1 plus y2 divided by 2, and again, it's a coordinate, so it's in parentheses. So in this first example, I'm dealing with M and T, I said. So I've got -4 plus 9 divided by 2, and the y's would be 2 plus 3 divided by 2. So when I do this here, I get negative 4 plus 9 divided by 2. That's going to get me 5 over 2, comma 5 over 2. Or if you used your calculator, you would have gotten an answer of 2.5, comma 2.5. Either one's acceptable. It doesn't really matter which version you use. All right, so for the second one, let's do the same thing. So we're going to find the midpoint of AH. And in this case, again, now we're going to be using A and H's coordinates. So I've got negative 1 plus 6 divided by 2, and I've got negative 3 plus 8 divided by 2. So in this one here, we've got 5 over 2, comma 5 over 2. Once again, or if you got using your calculator, you got 2.5, comma 2.5. Whichever version you do is fine. You realize that you, in fact, do have over here. Oops, what happened there? There we are. Oops, going all over the place. We've got the two midpoints are, in fact, the same thing. So now I can say for certain that, again, whichever one you have here, that these two here, so both midpoints are the same for each diagonal. Therefore, the diagonals bisect each other, making quadrilateral MATH a parallelogram. And that's basically our first part. In this case here, I'll just call it part A. So now that we know it's a parallelogram, my second part here, which is part B, is proving that it's a rectangle. So again, I can't be a rectangle unless I am a parallelogram. So I have that on a parallelogram, so that part's done for me. So now I got to show the rectangle properties. Again, you have various options. I like to focus on the diagonals because in a rectangle, we know the diagonals are also congruent to each other. So I would start off by saying the distance of MT, and again, distance formula is x2 minus x1 squared plus y2 minus y1 squared. All right, so in this case, again, focusing on M and T first. Again, who you call x1 and y1 and x2 and y2 does not really matter as long as you keep the order the same for both of them. So in this case, let's simply say negative 4 minus 9 squared plus 2 minus 3 squared. So when I do that, I get negative 13 squared plus negative 1 squared. That gives me 169 plus 1, which is the square root of 170. Now, I'm going to stop there. I'm not going to try and simplify 170, even though I can, because even if I could, I mean, there's no reason to, because I'm just trying to show that the two things are equal. So as long as I get this answer for the other one, I'm good. So even if you could simplify it, I recommend not simplifying it, just leaving it here so that we have that value. The second diagonal is AH. So let's find the distance of this one. So again, first x minus the second x squared plus the first y minus the second y squared. So I get here, this is going to be negative 7 squared plus this is going to be negative 11 squared. Square of that is 49. Square of negative 11 is 121. Add those together, I get square root of 170. So again, those two are equal to each other. So big part here is, again, conclusion is that, so since MT is congruent to AH and MATH is a parallelogram with congruent diagonals, then MATH must be a rectangle. And that is your conclusion for that part. So again, to me, this is the simplest and most direct means to proving both of these, both a parallelogram and a rectangle, using the diagonals, but you do have a lot of different options, especially for the parallelogram. Parallelogram, you have a couple different things. Just to kind of recap our properties, we know that we do have opposite sides that are parallel. So we could have shown that this side and this side were parallel, along with this side and this side. So I could do two slope formulas for MA and MT, slope formula for MH and AT, showing that they are equal to each other. That would show that I have two pairs of opposite sides parallel. Could have also shown that MH and AT were equal in length, along with MA and TH were equal in length. That would show the property that opposite sides are congruent. That also proves that it's a parallelogram. The other one that is commonly used is also showing that one pair, let's say the yellow, for example, is both parallel and congruent. But if you're going to do that one, remember you have to use the same side. So again, I was thinking about using the yellow one, so MH and AT. You can show that that's both congruent with the distance formula and parallel using the slope formula. You can't do one pair parallel and one pair congruent. So I couldn't do the yellow lines parallel and then the green lines congruent. That doesn't prove it's a parallelogram. It is possible to be other shapes, such as an isosceles trapezoid. So be careful that if you're going to do parallel and congruent, you have to use one pair of opposite sides. All right. The other thing is, if you were looking for the rectangle part, again, I like the diagonals. I think that's the best way, in my opinion, the fastest way to do it whenever possible. But you could have also shown that adjacent sides are perpendicular to each other, because once I know it's a parallelogram, if I can prove that one of these angles is a right angle, then I can say that the opposite angles, and therefore all four of them, are 90 degrees. So I have a rectangle by means that it's a parallelogram with four right angles. So it's another option for you to use. But again, I like focusing on the diagonals. I think it's kind of the nicest and simplest way, most direct route, regardless of what kind of information you have. All right, and that's all we have here for this video lesson number 10. Take the opportunity to try them on your own.